This unit is all about moles and how we can use it as a conversion factor to make calculations a lot easier in chemistry. So if you look at this example here, if we had a bunch of sand, it would be hard to count every single grain. So instead they can measure it by counting the grains in maybe one scoop of sand and then doing scoops instead. That's what a mole is. We use it to count the number of atoms or particles or maybe mass. There's a bunch of different things we can use with moles to use it as a conversion factor to make it a lot easier to count things or measure or find the volume of things inside of our atoms instead of having to see such microscopic sizes and things. So there's different ways you can measure something. You can go by mass. You could measure something by count, so counting each individual one, or you can measure something by volume. If you looked at this picture here, mass would be like your bird seed. Instead of counting every single seed or putting them in a certain thing and doing the volume, we count it by a certain mass. And that's how you buy your bird seed. Count would be your screws, because you buy a box of screws, you usually are buying a number of screws specifically. And then anything that's usually liquid, you usually buy by the volume. And you can go from one to another using different conversion factors. So first we're going to go by mass. For measuring something by mass when it comes to chemistry, we're going to use the molar mass, which is just the number of grams of an element in 1 mole of that element. The atomic mass on our periodic table is the atomic mass of the element with the units in grams per mole instead of atomic mass units. So whatever your weighted atomic mass is from the periodic table is going to be your molar mass of that element. If you have a compound, you add the molar mass of every atom present in the compound. So if I had like H and Br, I would add the molar mass of H and the molar mass of Br and put those together. If I had HBr2, I would have 1H and then add up 2 bromines, add up the mass twice for bromine. So whatever you have inside that compound, you just add up the molar masses of that to get your molar mass of your compound. They are always equal to 1 mole. So whether you have just one element, it's how many grams per 1 mole, or whether you have it in an entire compound, it's still grams per mole. So whatever that molar mass is, no matter how many grams it is, it's always equal to 1 mole. We can use that molar mass then as a conversion factor to convert between grams and moles and go back and forth. Here's an example. 1 mole of things will look slightly different. These are a couple different elements and 1 mole of those elements. So exactly so many grams of that element specifically looks a lot different. These are all 1 mole because they're equal to the number of grams that element has for its atomic mass. Elements, you find the molar mass on the periodic table and round it to 0.01 grams per mole. So all you have to do for your elements again is look at your periodic table and find what it says for your atomic mass. That is your molar mass. In compounds, you add the molar mass of every atom present in the compound. So in this case, if I had C6H12O6 glucose, 180 grams of that is the molar mass of it, because I add up 6 carbon, 6 oxygens, and 12 hydrogens. Add up the mass of all of that to get my total mass of 1 mole of it. And same for anything else. 1 mole of water molecules, I have a molar mass of 18.0 grams per mole. For H2O, because hydrogen, if I look at my atomic mass, is 1.01 plus 1.01 because I have 2 hydrogens plus oxygen, which is around 16. So 16 plus 1 gives me 18 grams. So that's how many grams per mole. That's my molar mass of H2O or water. Here's a couple practice ones with the answers so you can kind of look. Zinc is just an element by itself. So I would just look it up on the periodic table. I get 65.4 and my unit for molar mass is grams per mole. N2O, I have 2 nitrogens and 1 oxygen. So I would add up what nitrogen is twice because I have 2 of them, and then add up what oxygen is to get 44 grams per mole. Beryllium chloride, I have beryllium, add that up with 2 chlorines, so I can either take my chlorine's atomic mass times 2 and then add it to beryllium, I'd get 80 grams per mole. And then here when you have a polyatomic ion, one thing you need to notice and remember is that this 2 here means I have 2 polyatomic ions. So I have 2 NH4. So I can add up N plus 4 H's and then take that entire value times 2 because I have 2 polyatomic ions plus a sulfur plus 4 oxygens. Another thing you could do instead of adding up NH4 first and then taking that times 2, you can distribute this 2 to each element inside. So I'd actually have 2 nitrogens, and 2 times 4 is 8 hydrogens. So I'd have 2 nitrogens, 8 hydrogens, 1 sulfur, 4 oxygens. Add those all up to get 132.18. Or again, you could do NH4, add that up as a total for the polyatomic ion, and you have 2 of those polyatomic ions, so you take that times 2 and then add your sulfur and your oxygen and your 4 oxygens. Another thing you can do is you're welcome to go through the polyatomic ions sheet that you have and to calculate the molar masses to save you time, and then just treat them as an element. Another thing we do is dimensional analysis. So this is when we're doing conversions, you actually use dimensional analysis. All you really need to know is the conversion factors and how to use it. Really, you can use this to calculate about anything. I use it at the grocery store all the time. You can use it to figure out how fast somebody's going or how long it's going to take you to get somewhere. Dimensional analysis is really cool. It's my favorite part. So if I want to know the mass of 90 average size apples, if a dozen apples has a mass of 2.0 kilograms. So my dozen apples, remember a dozen is 12, have a mass of 2.0 kilograms. So down here, those are my conversion factors. I'm going to start with my given, whatever I'm trying to find. So what is the mass? I'm looking for mass of 90 average size apples. So I start with 90 apples because that's what I'm starting with. So I write 90 apples. I know that 1 dozen is equal to 12 apples. So 1 dozen is equal to 12 apples. And you want your units to cancel out. So here in this case, I'm using apples. So my apples on the top, I need to have apples on the bottom on this side because I need my units to cancel out. So I have 90 apples, and that's equal to, and I have 1 dozen apples is equal to 12 apples. So my apples is now canceling out. Now I want to convert, I know 1 dozen apples has a mass of 2.0 kilograms. So if I have 1 dozen apples is equal to 2.0 kilograms of apples. That's my other conversion factor. So that is sticking right here. Your conversion factors, whatever is equal to each other, will always go one on top of the other. In this case, I have dozen apples on the top. And to cancel that unit out of dozen apples, I need to put 1 dozen apples on the bottom. So my dozen apples now cancels out. So my apples canceled out because 1 was on top, 1 was on bottom. And now my dozen apples cancels out because 1's on top, 1's on bottom. So now I'm left with kilograms of apples. And that is what I'm looking for because I want to find the mass of 90 average size apples. So I'm looking for mass. Kilograms is a measure of mass. So I know that I'm in the right area for my answer. I know that there are 2.0 kilograms per 1 dozen. So 2.0 kilograms per 1 dozen apples. After I do all this, I multiply everything across the top. So 90 times 1 times 2. And then divide it by 12, divide by 1. And I get 15 kilograms of apples. Here's another example for you just to see if you want to look at really fast. If you have a bushel, that's equal to 1 dozen, and a dozen apples is equal to 2 kilograms. Those are 2 different conversions. What is the mass of 0.5 bushel of apples? So I always start with my unknown, my given here. 0.5 bushel is what I'm starting with. I know that 1 bushel is equal to 1 dozen apples, so that's my conversion here. I'm going to put bushel on the bottom so that I can cancel out that unit because I don't want my answer in bushels. I want my answer in kilograms. So I have 0.5 bushel is 1 dozen apples is equal to 1 bushel. My next conversion factor is I know that 1 dozen apples is equal to 2.0 kilograms. I'm going to put the dozen apples on the bottom so my dozen apples unit can cancel out again. And then I take 0.5 times 1 times 2, divide by 1, divide by 1 to get 1 kilogram. One last practice one here. Assuming 2 kilograms of apples is a dozen, and that each apple has 8 seeds, how many apple seeds are in 14 kilograms of apples? So I'm looking to get into apple seeds at the end. I'm starting with 14 kilograms because that's my given. 14 kilograms, I know there are 2 kilograms in 1 dozen, and I know that 1 dozen means 12 apples, and I know that 1 apple has 8 seeds. Now notice these are all my conversions, everything that's on top of each other. So 2 kilograms in 1 dozen, 12 apples in 1 dozen, 8 seeds in 1 apple. And then which one goes on top just depends on which units I'm trying to cancel out. So I'm starting with kilograms, so I need kilograms on the bottom so I can cancel out those units. Now I have dozen. I want dozen to cancel out, so my dozen in the next step is going to be on bottom. Now I'm in apples. I want my apples to cancel out because I'm looking for seeds. So I put apples on the bottom here so that apples can cancel out. And then now I have 8 seeds, and seeds is what I'm looking for, so I can stop. Then I do 14 times 1 times 12 times 8. Divide by 2, divide by 1, divide by 1. And that's 672 seeds. So if you know the molar mass, which is what we were calculating at the very beginning, you can use dimensional analysis, those steps of using conversions and units and canceling those out. You can use that to convert between grams and moles. So if you have this table thing, your mole island, you can add right here molar mass is how you go from mass to moles. Moles to mass or mass to moles. And mass is measured in grams for our sake. A couple practice ones, if we have 2.3 moles of lithium to grams, you would start with 2.3 moles. You have, look up your molar mass of lithium, because that's in grams per moles. So you have 2.3 moles of lithium on the top, that's your given, that's starting out. You would need to put 1 mole on the bottom and your molar mass of lithium on the top. Then you multiply across the top, divide by the bottom. You can get your answer. Converting 26.7 grams of H2O to moles of H2O, you start with the 26.7 grams of water. You need to add up what 2 hydrogens and 1 oxygen would have for a molar mass. And remember, that's a conversion factor, how many grams per 1 mole. So when I add that up, I get 18 grams per mole. So I'd put my 26.7 grams on the top. I want grams to cancel, so I need to put grams on the bottom. So I have 18 grams per 1 mole on top. So I would do 26.7 times 1 divided by 18 to get 1.48 moles of H2O. Converting 5.1 moles of AuPO4, so gold phosphate, in this case it'd be gold 3 phosphate, to grams. I have 5.1 moles, so I start with 5.1 moles. I add up what gold plus phosphate plus 4 oxygens would equal for my molar mass, and remember that's in grams per mole, so that's my conversion. So I have 5.1 moles, so I need to put my 1 mole on the bottom to cancel out my moles, and then I'll put my grams per mole, my grams of AuPO4 on the top. So that is how you do your conversions. Set these up and see if you can figure them out yourselves.